Today we're going to be learning about data acquisition systems. We're going to start with an introduction to our company and data acquisition. We will learn about commonly used RS485 serial and Modbus RTU protocols, which communicate over 2 copper wires and are used in many different industries. We will learn about Ethernet-based Modbus TCP, which is similar to Modbus RTU. We will also learn about CAN, the Controller Area Network Protocol, DeviceNet, and PROFIBUS protocol-based data acquisition. We will also go over applications and PC-based control and monitoring software. Then we will go through some questions. ICP-DAS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP-DAS USA was launched in 2001 to support the North and South American markets. We have over 200 R&D engineers in Taiwan. We work closely with them to add new features to products, develop new products, and to support our customers. Almost all of our products are RoHS compliant, which means they're lead-free. We have our ISO 9001 certification, which is related to quality management systems and ensures we meet product statutory and regulatory requirements. Data acquisition is the process of sampling real-world physical information and the conversion of those samples into digital numeric values that computers and controllers can understand. Programs can be run on computers and controllers and can take that information and implement control logic operations like turning on a fan based on a temperature, turning on a pump based on a tank level, or opening a valve based on pressure levels. The picture on the left shows a groundwater monitoring application at a landfill. There is a control panel at the landfill with some data acquisition equipment, which is taking temperatures. There's a cellular modem and a controller in the control panel that is sending the data back to an off-site location. Landfill operators can see the data on a computer and can see data log reports that show the trend of the temperature over time. The NS205 at the top left is an industrial Ethernet switch. The picture on the right shows a PLC programmable logic controller that is connected to various equipment like data acquisition modules, a data acquisition rack, motors, a keypad on a door, and a camera. A program can run in the controller and can implement instructions like triggering outputs and collecting data based on the inputs. The data can be stored in a database on a computer. Analog is a continuous signal that can vary over time, like current, temperature, or voltage. Current, which is analog, for example, can be used to dim or brighten a light. Digital is either on or off, like how some lights can just be either on or off. ICP-DAS started in 1993 when it bid on a project for the Taiwan government. These I-7000 modules were designed based on specifications for the project. They communicate over RS485 ASCII protocols called DCON protocol. ICP-DAS developed a patented tuner that automatically tunes the data rate and data format for robust communications. There are more than 70 selections of analog, digital, and specialty I/O modules. They are available in configurations like RTD, thermistor, and thermocouple for temperature inputs. They're also available in voltage and current inputs and outputs, which are used for taking in or putting out measurements like flow or pressure. Frequency or counter input is often used for counting or keeping track of position in applications. Digital input and output are used for turning things on or off. Relays are used for applications like routing and signaling railways. I-7019R is a universal analog input module, communicable over RS485. It has high voltage protection on its differential inputs. The high voltage protection helps the inputs not to burn out if there is a spike in the input signal. Differential inputs provide a more stable reading if there is EMI, electromagnetic interference. With this module, each channel can be configured to a different input type. One channel could be milliamp, which is current, another could be voltage, and there could also be thermocouple, which is temperature. I-7017 is an analog input module that can measure voltage or current. If you want to measure current, you can open up the module and insert a 125 ohm resistor inside and close the module back up. It has 8 input channels. I-7017 is being used in the energy industry with solar panels, wind turbines, and inverters. The solar panels and wind turbines produce DC direct current energy. The inverters convert the DC direct current energy into AC alternating current that can be fed into a commercial electrical grid. DN843I is a current input sensor board that can put out voltage. I-7017 can take that voltage so it can be brought back to a computer for data logging, control, and monitoring. I-7561 converts the RS485 signal, which I-7017 communicates over, into USB, which most computers support. NASA is using I-7019R and I-7018 data acquisition modules for measuring temperatures and strain in their heat treatment facility and creep testing lab. The modules are daisy-chained together over the RS485 bus. Strain and thermocouple sensors are connected to the terminal blocks of the I-7019R and I-7018 modules. Decon Utility is a software tool we provide for use with our RS485-based data acquisition modules like the I-7000 series. It can be used for configuring the input and output types, addresses, and baud rates for the modules. The M-7000 series is just like the I-7000 series, but it can also communicate over commonly used Modbus RTU protocol. They, like the I-7000 series, are small and can fit in the palm of your hand. They can also be daisy-chained over the RS485 bus. Many other vendors have devices that communicate over Modbus RTU. Our M-7000 series can be used with other vendors' PLCs that support remote Modbus RTU-based I/O modules. They, like the I-7000 series, are configurable with Decon Utility and can be mounted on a DIN rail. We came out with the smaller TM series that are similar to the M-7000 series and support both Modbus RTU and Decon protocols. They are about half as big as the I and M-7000 series products. They are configurable with Decon Utility. Zigbee wireless I/O modules are like the M-7000 series, except they need a host converter to be able to communicate back to a PC or controller. They support Decon and Modbus RTU protocols. They are set up with some dip switches on the side of the product so they can be in the same wireless network and have a unique address. They are used for applications like building, factory, and machine automation. At the bottom right of the image, you can see a host converter connected to a PC. Each Zigbee network needs a host converter to act as the coordinator for the network. It helps to establish the communication path between the computer and the end devices. The PC holds a control and monitoring program, so operators can see the status of the factory, and they can also turn things on or off as necessary through the program. To the left of the host converter, you can see a Zigbee I/O module, which can be used to turn things on or off based on conditions. At the top right of the picture, you can see a Zigbee slave converter is attached to a touchscreen HMI human-machine interface. With it, users can input things like the number of pieces of material a worker cut with an industrial saw. The image also shows other I/O modules and devices connected to the wireless Zigbee network for providing information for control and monitoring. Like the I-7000 and M-7000 series, we have a similar ET-7000 series that supports Modbus TCP protocols and communicates over Ethernet cables. You can use industrial Ethernet switches like NS205 or other Ethernet switches with them. They have a web server inside for configuration. They have an IP address, and you can also upload images to them to show inside of the web server. For example, if you were monitoring tanks, you could have a page that shows a graphic of a tank above the data, so it's clear to the viewer what kind of data is showing. You can also make different labels in the user interface to show what kind of data is being acquired, like fan, light, pump, motor, and things like that, right next to the input data. You can use a standard web browser and the module's IP address to pull up the web server for configuration and monitoring. ET7017 has 8 analog input channels and 4 digital output channels. It has a built-in dual watchdog, so it will reset itself if there are any hardware problems or software problems, like if the module isn't communicating or if it locks up. It supports I/O pair connection, so the input on one can trigger the output on another. To set them up, you can connect them directly to a PC, or you can connect them to a switch or hub to get them on the same network. Mini OS 7 Utility is a software tool we provide that allows you to search and find our Ethernet products on the network. You can use it to set the IP addresses of our Ethernet controllers and data acquisition equipment. To access the web server, you can open a standard web browser and enter in the configured IP address. You also need to enter the username and password.
In the emergency warning system of a tunnel, we need to control the cameras and to receive signals from smoke sensors and transmitters. But how can we build such a long distance and immediate transmission control system? Offered by ICP DAS, ET7000 modules can be linked to devices like cameras, smoke sensors, and transmitters. ET7000 modules can send their signals to the Internet, which provides immediate and long-distance transmission. ET7000 modules can also send digital output signals to remote devices. Other devices can also receive data from the web. For example, web-based LED displays can display the warnings to keep the roadway smooth and safe.
The PET7000 series can communicate over Ethernet and Modbus TCP like the ET7000 series. It can also be powered by a Power over Ethernet switch. Power and data can be sent over a standard Ethernet cable. Modbus TCP-based data acquisition equipment can be interfaced with through a web browser or with software tools like SCADA software that supports Modbus TCP protocol. Our remote I/O modules are being used for monitoring temperatures on wind turbine blades to help measure performance. Our ET7018Z, M7018, and I-7018 can be used to monitor temperature since they have thermocouple inputs. We also have TET and TPET Tiny Ethernet and Tiny Power over Ethernet modules that are similar to the ET and PET modules but are smaller in size. They support Modbus TCP protocol. We also have rack-based data acquisition equipment that uses cartridges that go in racks that communicate over different protocols like RS485, Modbus RTU, Modbus TCP, PROFIBUS, CAN-open, DeviceNet, USB, and more. We provide a wide range of cartridge-based I/O modules. Rack-based solutions can offer a large number of I/O in a small space. Modbus TCP-based racks can communicate over the Internet or Ethernet and can interface with computers at a remote location. They can also allow serial devices to communicate back to computers through virtual COM ports, just as if they were connected directly to the computer, as you can see in the image. PROFIBUS is the Process Field Bus Protocol, an open digital communication system that is widely used in factory and process automation. It is suitable for fast, time-critical applications and complex communication. We provide remote and rack-based PROFIBUS data acquisition hardware that can communicate with PC or PLC DP masters. PROFIBUS products are widely used in applications like building automation, process control, environmental control and monitoring, and factory automation. CAN bus is the Controller Area Network and is a protocol that was designed for automotive applications. It is also used in aerospace, industrial automation, and medical equipment. It allows microcontrollers and devices to communicate with each other. A PC could have a CAN communication board inside and could communicate with a CAN I/O device over the network. The CAN I/O modules could be connected to various sensors for reading things like pressure and can also be used to interface with lights or other inputs and outputs in a vehicle system. DeviceNet is a protocol that is layered on top of CAN technology and is used in the automation industry for connecting control devices and exchanging data. It is more robust when compared to RS485-based protocols. We provide DeviceNet I/O modules for incorporation into DeviceNet networks. FRnet is an industrial field bus that was developed by ICP DAS. It supports high-speed deterministic I/O control and real I/O synchronization capabilities. FRnet can scan 256 I/O points at 0.72 milliseconds within 1,000 feet. The picture on the right shows you can daisy chain the FRnet modules together with 2 copper wires. The FR32R board is a relay output board that can be used to turn things on or off.
FRnet is a field bus developed by ICP DAS. It features high-speed and long-distance data transmission and is designed for digital I/O control. Most importantly, only 2 wires are needed to transmit data, making FRnet itself in the field simple and beautiful. Now ICP DAS has more than 20 kinds of modules supporting FRnet. Let's check out more of its unique features and actual applications in building automation. On the first floor, ICP DAS FRnet modules play an important role in the cubic parking system. They help to ensure cars are parked precisely in the correct positions. Once a car is parked out of the edge, a sensor will be activated. An alarm will be sent to the driver until the car moves into the correct position. Let's go to the second floor. On the second floor, a smoking room on the right-hand side features independent air conditioning. A smoke detector in the corner sends signals to the FRnet module when it detects smoke. The fan is turned on as soon as the FRnet module receives the signal from the smoke detector. On the third floor, the FRnet module controls the on-off function of the lights in the meeting room. With instant response time, the FRnet module has excellent performance in the digital control application. On the top floor, the status of windows and doors are monitored by the FRnet module. When any window or door is opened, the FRnet module will instantly detect it and send its status to the control center in real time. Through the nature of FRnet, data is sent through 2 wires. Imagine that! Throughout the whole building, from the first FRnet module to the last, only 2 wires are needed. FRnet makes installation simple and neat. Shown on the left here, I-7188EF-016 is an embedded controller with FRnet ports. It receives data from FRnet modules and sends data to the control center through Ethernet communication. We can see detailed information coming from all of the FRnet modules in the building on remote computers. Replacing FRnet modules is as easy as playing with Legos. Replacement has 4 steps. First, unmount the broken one. Then, mount a new one. Then connect the terminal blocks with the new module. Then set the dip switch on its panel. Believe me, everything is done and the new FRnet module is working now. Thanks to ICP DAS engineers, many user-friendly designs have been added to FRnet modules panels. There are 3 LEDs at the top of the panel. The last one, Error, indicates incorrect wiring or bad communication in the field. This design helps users to locate problems easily on the spot. At the bottom of the panel, there's a dip switch for configuration. No computer or laptop is needed. Just by moving your fingers, the FRnet module is ready to work. The embedded controller I-7188EF-016 has 2 FRnet ports to handle data from FRnet modules. Up to 16 FRnet modules can be connected with I-7188EF-016 simultaneously. Users can also write their own programs for I-7188EF-016 to control the FRnet modules.
USB-based remote I/O is convenient for small data acquisition applications using the USB port on a computer. You can use many of them in one application with a USB hub, like our USB 2560. You can make PC-based applications for them using Visual Basic, C++, or other Visual Studio.NET based applications. We provide libraries for program development. We also provide PC-based data acquisition boards that can fit in the PCI slot in a computer. We also provide older ISA boards, for older computers. Since the PC board is installed inside the computer, you need to run a cable from the PC board to the interface or daughter boards, which are used for wiring to different sensors and equipment. Energy management systems help with monitoring power consumption and energy usage. Monitoring energy can help you save on costs, since changes can be made to reduce energy usage when it's not needed. SCADA control and monitoring software can be used to display the data in a way that's easy to understand and analyze. Power meters can be used to gather kilowatt hours and energy consumption data. Power meter concentrators can be used for logging and displaying power meter information. Data logger devices like power meter concentrators allow information to get logged on a micro SD card in a CSV comma-separated value format that can be opened in Microsoft Excel.
Easy Data Logger is a free software designed for ICP DAS users to easily and instantly build a SCADA system. With Easy Data Logger, we will show you how simple it is to quickly establish the SCADA environment. Before everything starts, we must do some preparation. First, we need a 24-volt power supply and two ET7000 modules. On your left side, ET7017 is a web-based I/O module with analog input channels. On your right side, ET7052 is a web-based I/O module with digital input and output channels. We also need to link a scope meter to ET7017 for analog input, a button, and LED lights to ET7052 for digital input and digital output signs. Just link all the devices together and it will be like this. Now we can start to run Easy Data Logger. Run the application and you'll see the built-in groups Traffic Light and Component on the left side. We're going to build a new group. Click Group Setup and then we can see the group setting window. Now we can see 3 steps here. By following the steps, we'll finish establishing this SCADA system. Let's start the first step. Click Install. The driver window will pop up. Here we have to set the communication mode between the modules and the PC. Since ET7000 modules communicate with the PC by TCP protocol, we choose Modbus TCP. Next, we have to enter the IP address of the module. You'll find the IP addresses in the manuals of ET7000 modules. In order to recognize the modules conveniently, we set the end of ET7017's IP address at 17. Click Install when the IP is entered. We find the IP of ET7017 we just entered is in the block of Step 1. This represents we have successfully added ET7017's driver. Follow the same steps to install the other module, ET7052. Choose Modbus TCP and enter the IP address. We will set the end of ET7052's IP address as 52 for convenient recognition. Here we can see that ET7052's driver has also been successfully added in the driver list. Now on to the second step. In this step, we're going to add ET7017 and ET7052 into the device list, which means that we're going to activate their channels. Click Add under the device list. The system shows the configuration window. Click the arrow and go to the next page. Here we can see the IP added for the Modbus TCP devices on your left side. Now we can give them nicknames. Attention! To prevent errors, we shall not use the minus sign in the nickname. We will name the ET-7017 module as ET_7017. Next, we have to set the address range definition. Since ET7017 has 8 analog input channels and 4 digital output channels, we set its AI addresses from 0 to 7 and DO addresses from 0 to 3. Click Add, and those channels are now in the AI and DO lists. Use the same method to activate the channels of ET7052. Name it, set the DO from 0 to 7 and DI from 0 to 7. Click Add, and those channels are now in the DI and DO lists. Let's check if all the channels have been activated. Good! Now it's time to build the group for our SCADA system. Click Add in the Work Group column. We will name the group as ET7000. Now we are going to do step 3. In this step, we can add the channels into the ET7000 group. Just choose the channels you want to add and click the Add below. For this demonstration, we will add all the channels into the group. You'll see all the added AI channels in this frame. Let's add the rest of the DI and DO channels into this group. ET7017 AI_0 is the channel that links into the scope meter and receives analog input signals from it. We have to configure the analog input parameters before the system is done. Choose ET7017_AI_0 and click Modify. We can see the Modify channel window. Refer to the ET7000 User's Manual and you'll understand how to set it. Click Modify to save the values. All 3 steps are finished. Press the Home button at the bottom right to get back to the main screen. Now we can see the ET7000 group on your right side. We can start running the group by clicking Start. At this moment, the red signs turn into green signs, which represents that the system is running successfully. Now it's showtime. Let's see what Easy Data Logger's got. Click Gauge in ET7000 group to enter the gauge window. The first one is the gauge for ET_7017. When we change the value from the scope meter, we can see the gauge value changing with the scope meter at the same time. In less than 5 minutes, we set up an analog input data acquisition system. Easy Data Logger also provides trend recording, another convenient tool. Click Trend and select ET_7017. The real-time record will show immediately. Layout is also a great interface for controlling and monitoring digital input and digital output. We can use the cursor to control digital output here. When we click the on-off button on the screen, the LED light, which links to the ET7052's DO channel, turns on and off simultaneously. The digital input will also be shown on the frame promptly. When we switch the button, the layout shows whether the input is on or off. Let's go back to the trend. By selecting digital input channels into the monitored variables, their movement will instantly be shown. Exporting the data is the most important thing Easy Data Logger does. Before that, we have to stop the system. Click Open Database. Choose which database and group you want, and then we can load trends or tables from the database. By clicking the Export button, you can also export the table into Excel files for further analysis.
Easy Data Logger is a free PC-based control and monitoring software that we provide free with our data acquisition modules. You can use it to send email alarms based on conditions, log data, show information on a screen, or to implement control. You can use it with other vendors' Modbus products as long as you have one ICP DAS Modbus product in the network. It supports up to 64 I/O tags, which are words tied to memory locations in the computer that represent the input and output channels from data acquisition equipment. You can also display and log from web cameras and can send SMS or email alarms out based on information from the system. You can also set up virtual channels that can hold information, like if you want to take 5 channels and then take the average, you could use a virtual channel to hold the average. Easy Data Logger supports layout pages, so you can get graphics from the graphics library and map them up to I/O equipment so you can visually see the status of tank levels, pressure readings, or the status of valves, motors, and other equipment. It supports trending, so you can see the status of the equipment in a graph over time. You can also log the data in an Access or SQL database. You can export the data to an Excel or CVS comma-separated value file. An advanced version is available that can support more channels, alarm contacts, and web cameras. Here is a table showing the differences between the basic and advanced versions of Easy Data Logger. The free version supports up to 32 virtual channels, and the advanced version supports up to 256. The free version supports 1 web camera, and the advanced version supports up to 10. The free version supports 2 alarm, SMS, or email alarm contacts, and the advanced version supports up to 10. The free version supports 64 I/O tags, and the advanced version supports up to 1024. The advanced version costs $629, and you can install it on up to 3 PCs. SCADA is Supervisory Control and Data Acquisition. SCADA software runs on a PC and allows you to interface with various equipment like data acquisition modules, PACs, programmable automation controllers, PLCs, programmable logic controllers, embedded controllers, and instrumentation devices. It comes with a graphic library that you can use to create a visual user interface that represents real applications. They also support scripting, so you can implement some control logic through some basic programming commands. They support multi-level user management for security. Different users can have different permission levels. In this picture here, you can see there are 3 different areas that have a PLC connected to a touch panel and some data acquisition modules. They are connected to a hub or Ethernet switch and a web camera. They are networked back over Ethernet cables to a PC running Indusoft SCADA software. You can monitor and control the system from each area or from the PC running SCADA software. Indusoft has multi-language support, so you can create your program in English and then easily convert the system into another language like Spanish. We provide some PAC programmable automation controllers that have Indusoft built in. SCADA software can be set up to be web accessible over a web page and can automatically send email and SMS alarms. KingView is another SCADA package for PC-based automation systems. It is being used for applications like machine control, factory automation, wastewater management systems, building automation, and security systems. It uses static picture files and can support animations. SCADA packages are sold based on tag counts. Tag variables represent actual I/O data that map up to data acquisition equipment, controllers, and instrumentation devices. The development full package provides a development and runtime license in one USB hard key. When the USB key is left in a PC running the SCADA software, it is licensed and can run. The development packages allow for development of systems, but don't allow you to run them. Runtime packages allow you to run a SCADA system and don't provide any development options. They are good for developers that want to build a system and then sell it without modification options on board. Unlimited tag versions are available for very large systems. KingView has been used in applications with over 10,000 tags. KingSCADA is another SCADA package. It provides vector-based graphics which are dynamically built as the software is running. It is faster than image-based graphic software like KingView. It also supports model objects, so you can create a pump once and then copy it 500 times throughout a program. If you want to update all 500 pumps, you can update the model object once, and the update will propagate through the entire SCADA system. This saves a lot of time during development and maintenance. ICP-DAS USA can provide customized products and can modify products to meet customer needs. We have a large inventory, and for out-of-stock items, we offer low lead times and can usually ship within 5 to 7 days. We offer both hardware and software solutions. We're capable of providing programming services in case anyone needs some extra help or needs to get an application out right away. We provide free technical support and provide free online web-based training every month. We provide modular total solutions which can be used in many different industries and environments.